Hello students and family members, this is Mr. Panza. Today, in the video lesson, we're going to be discussing how we can measure angles using a protractor. And there are 5 simple steps that you can follow each time to answer this question that we're looking at. Let's take a look at the steps. Step 1. You need to locate the angle that you're trying to measure, name it by identifying the points. And then you need to extend the line with the ruler or the back end of the protractor so that if the line doesn't quite meet the protractor's length, then you'll still be able to see it. You'll be able to recognize this once I show you an example. Step 2 is simply identifying what type of angle you're looking at by naming it in your mind, and then I also have students write it down. Is it a right angle, an acute angle, or an obtuse angle? Step 3 is lining up the vertex of the actual angle with the bullseye in the protractor. I'll talk more about the vertex and the bullseye once I give you an example. Step 4, lining up the bottom line segment of the angle with the T horizontal side-to-side line on the protractor. That seems a bit confusing, but again, once you see the example, it'll make more sense. Then finally, once you've identified that angle that you're measuring, you take a look at the protractor and you'll be able to measure your angle. So let's take a look at an example. Let me shrink down our steps so we can still see them, move it over to the side, and then also let you see the example that I'll be talking about. First, let's take a look at our steps. Step 1 tells me to locate the angle and name it. We're fortunate with this angle because it's already given us 3 different points: point D, point E, and point F. Because they've given us those names, then we don't have to name them. They've already named this angle, angle DEF. You can also call this angle, angle FED. And we know that the angle we're trying to measure right here is the space right in between, or this one dot, this one point. This point is extremely important for a couple of reasons. Remember when we looked back at step 3, we talked about a vertex. The vertex are where 2 line segments or 2 lines meet in the middle. And in this case, line segment DE meets up with line segment FE at this vertex, point E. That means that vertex needs to match step 3 in our directions. Before we get to step 3, though, we need to take a look at the first 2 steps a little bit more in detail. Step 1, locate the angle. We have done that already. And then extend the line with a ruler. Now, you may not understand why we're doing this right now, but you'll understand once we try and actually identify how big this angle is at the end. You don't want to take this flat line angle and extend it. That's always just going to remain flat on your page. Instead, you want to take this line that's a little bit lifted off the page, line it up with your vertex point, and then just extend that line as far as it can go on the paper. Because once we eventually pull this protractor out to measure, we're going to want to make sure that we don't have to remove the protractor and try and line it up just by eyeballing it. Instead, we'll be able to see where exactly that line matches the protractor measurements. So now that we've extended the line, we're ready to name this angle in our mind. So we've been talking about different types of angles: right angles, acute angles, and obtuse. Right are 90 degrees, acute are less than 90, and obtuse angles are larger than 90 degrees. Well, this angle, if a 90 degree would be perpendicular going straight up and down, is clearly larger than 90 degrees, which means this angle here, when I name it in my mind, is obtuse. I've actually told the students to make sure that they write it down as well, to make sure that they remember when they're measuring the angle, what is it? Is it an obtuse angle or an acute angle, or maybe it's right? Finally, we're ready to grab our protractor. I want to point out a couple of things first of all on this protractor. At this T horizontal line, is what I'm calling it, you'll notice that there is a blank wide open space right here. That wide open space is what we call the bullseye. I call it a bullseye because it reminds me of a dartboard, and on most dartboards that bullseye is fairly small, and it's the hardest part to hit on the dartboard. Well, it's not that hard to hit in a protractor. It's still the smallest and reminds me of the bullseye, which is why I've named it the bullseye. This bullseye, that circle, that space right at the T mark, needs to be lined up directly with this E, and you can do that a lot of ways. So I'm going to go ahead and line that bullseye up with my vertex. Step 4 tells me that after I've lined up the vertex with the bullseye, I now need to take the T segment. Here's the T segment on my protractor. It makes what looks like an upside down capital T. If you can't see it, let me bring it a little bit closer so you can see it. When I look closer at the protractor, I can see that this is a T mark, where my bullseye has that spot right there. This line right here, or this line, needs to match up perfectly with your bottom line. So after I've matched up my bullseye with my vertex, I now need to spin this protractor all the way around until that line matches, and it looks like I have a perfectly straight line segment on the protractor connecting all the way out to point F. And now you're done with line 4 and ready to look at the angle measure and write down that angle measurement. Well, we're looking over here at line segment ED to see what the actual measure of the angle is. Well, because I extended that line segment way early on in the process, I can see that point D would have ended here and would have had to try to extend it out myself. Instead, I've drawn the line already, and I can see that this line extends all the way to the 170-degree marker, which means this angle here is 170 degrees. Now let's take a closer look again at our protractor, and more specifically at the 170-degree mark. You may have been asking yourself, how did Mr. Panza know that it was 170 degrees and not 10 degrees? That brings me back to step 2, when in our mind we were trying to name the angle. Because if we were able to see that this was a small angle or an acute angle, we would have then looked at our protractor and said, oh, well, clearly the smaller angle here, less than 90, has to be the 10-degree marker. However, this one was an obtuse angle. So even though a protractor shows us a 10-degree marker, we know that the answer is actually 170 degrees because that's the marker for the obtuse angles. And that's how you use these 5 steps to measure an unknown angle. Follow these 5 steps all of the time, and you'll be able to measure all angles using a protractor. Thanks, and I hope this was helpful.